Example on implicitly defined functions. Find dy by dx if 3y squared plus 2y is equal to 5x. So to find dy by dx, here I'm going to find the derivative of each term. Derivative of 3y squared is, I'm going to put down the power, so it's going to be 6y taken from the power 1 multiplied by the derivative of y, which is dy by dx, since y is not a function in x, so I should write dy by dx, plus derivative of 2y is 2 with respect to y, but with respect to x it's 2 dy by dx, and derivative of 5x is 5, and with respect to x it's dx by dx, which is equal to 1, so I don't have to write it down. Now I have dy by dx in two terms. By taking dy by dx as a highest common factor, so it's going to be 6y plus 2 is equal to 5. So dy by dx is equal to 5 divided by 6y plus 2. 5 divided by 6y plus 2. Find the slope of the circle x squared plus y squared is equal to 25 at the point 3 and negative 4. As we all know that the value of the slope of a function is the value of the derivative of the function with respect to x. So first I need to figure out what is the value of dy by dx. And here I'm going to use the implicit derivative to find the derivative. I'm going to use the implicit derivative since the function is not y, it's y squared. So let's find d by dx for the function x squared plus y squared, the left hand side, and d by dx for the right hand side, which is equal to 24. D by dx for the 25 is equal to 0. So it's 0. Okay? And derivative of x squared with respect to x is 2x dx by dx, but dx divided by dx is 1, so we are not going to write it. Plus derivative of y squared is 2y dy by dx. So let's rearrange the equation to be written in the form of dy by dx is equal. So dy by dx multiplied by 2y is equal negative 2x after moving 2x to the other side or subtracting negative 2x from both sides. Then I will divide both terms by 2y, so dy by dx is equal negative 2x divided by 2y, which is equal to negative x over y. So the value of the slope is negative x over y. So if I wanted to find the value of the slope at the point 3 and negative 4, I'm going to replace x with 3 and y with negative 4. So the slope is equal negative x over y. So it's negative 3 divided by negative 4, which is equal to 3 over 4. 3 over 4, it's a positive value. Don't forget that the graphing of the equation of the circle x squared plus y squared, its center is the origin and its radius is equal to 5. So it's a circle that its radius is 5 from all sides, because this is the negative direction of x and y. So we are talking about the point 3 and negative 4, it's somewhere here, and the slope of the straight line passing through this point or touch this point is 3 over 4. Find the tangent and the normal lines to the ellipse given by x squared minus xy plus y squared is equal to 7 at the point negative 1 and 2. To find the slope of the tangent and to find the slope of the normal, we first should find the value of dy by dx. dy by dx. And here we know that we are going to use the implicit differentiation, and that's why, because you have y square. So d by dx to the left hand side, which is x squared minus xy plus y squared, is equal to the derivative with respect to x of 7. Let's find the derivative step by step. Derivative of x squared is 2x, but notice now that xy is a product rule, u and v. So derivative of first, which is 1, multiplied by the second, plus derivative of the second, which is dy by dx, multiply the first, which is x, plus derivative of y squared is 2y dy by dx, since y is not a function in itself. So the derivative of any constant is 0. So let's simplify it. So it's 2x minus y minus x dy by dx plus 2y dy by dx is equal to 0. I need to rearrange the equation and take dy by dx here as a highest common factor, taking dy by dx here as a highest, there is dy by dx as a highest common factor. So by taking dy by dx as a highest common factor is going to be negative x plus 2y. And by moving negative y to the other side is going to be positive y, and moving 2x to the other side is going to be negative 2x. So I can say that after dividing both terms by negative x plus 2y, that dy by dx is equal to y minus 2x divided by 2y minus x. This is derivative of the function y with respect to x for this ellipse. If I wanted to find the equation of the, or slope of the tangent, if I wanted to find slope of the tangent, slope of the tangent line, all what I have to do is to plug in y with 2 and x with negative 1. So it's 2 minus 2 multiplied by negative 1 divided by 2 times 2 minus negative 1. Using calculator or without, the final answer is going to be 4 over 5. Negative times negative is positive, 2 plus 2 is 4. Negative times negative is positive, 2 by 2 is 4 plus 1 is 5. So this is the slope of the tangent. If I wanted to find the equation of the tangent, equation of tangent line here, gonna be y minus y1, which is 2, equal the slope x minus is gonna be plus 1, in the form of y minus y1 is equal mx minus x1, in the form of point slope form. Point slope form. But if I wanted to find the equation of the normal, I should first find the slope of the normal, right? Or slope of the normal is going to be the opposite reciprocal of the slope of the tangent. Opposite reciprocal of the slope of the tangent. Or I can divide negative 1 by 4 over 5. So it's negative 5 over 4. Opposite reciprocal of the slope of the tangent. So it's negative 5 over 4. Now, if I wanted to write down the equation of the normal line to the curve, it's gonna be y minus 2 is equal to negative 5 over 4 x plus 1 in the form of point slope form. Point slope form. Find the equation of the tangent and the normal to the line of the curve given by x to the power 4 plus xy minus y squared is equal to 0 at the point 1 and 2. We know that the first step we should find dy by dx, and to find dy by dx we should find dy by dx to the left hand side and the right hand side. So it's x power 4 plus xy minus y square. Derivative of any constant is give me 0. Derivative of any constant, it gives 0. Derivative of x to the power 4 is 4x to the power of 3. Then this is a product rule. So derivative of the first multiply the second plus derivative of the second, which is dy by dx, multiply the first, which is x, minus derivative of y square is 2y dy by dx. Now I have dy by dx here and I have dy by dx there. So I'm going to take dy by dx as a highest common factor. So dy by dx, the remainder here is x minus the remainder there is 2y. And by moving 4x to the power of 3 to the other side, it's negative 4x to the power of 3. And positive 1y is going to be negative y. So dy by dx is equal negative 4x power 3 minus y divided by x minus 2y. I wanted to find the equation of the tangent, so I'm going to find the slope of the tangent at the point 1 and 2. So x is equal 1 and y is equal 2. So slope is equal negative 4 multiplied by 1 to the power of 3 minus 2y, y, which is 2, over x, which is 1, minus 2 times 2. So it's equal negative 4 times 1 is negative 4 minus 2, negative 6, divided by 1 minus 4, which is negative 3. So it's equal to 2. So the slope is equal to 2. So equation of the tangent and the slope of y minus y1 is equal m times x minus x1 is y minus 2 is equal to times x minus 1. This is the equation of the tangent. But slope of the normal, we can call it as m2, is equal opposite reciprocal of 2. So it's negative 1 over 2. Opposite reciprocal. Opposite, it means opposite in the sign. Reciprocal, it means we flip the fraction. So equation so equation of the normal in the form of point slope form is y minus 2 is equal to negative half x minus 1. Use the implicit differentiation to find dy by dx in terms of x and y together, not only in terms of x. So to find the value of dy by dx, I'm going to find d by dx for both terms, the left hand term and the right hand term. So d by dx for 2x to the power of 3 is the normal derivative. I'm going to put down the exponent 3 multiplied by 2 is 6 and subtracting from the power 1. Of course I'm not going to write dx by dx because dx by dx is 1. For the second one, the derivative of 2y square is 4y after I put down the exponent and subtracting from the exponent 1, dy by dx. Why? Because y is not a function in x here. Or the derivative of y is dy by dx plus derivative of any constant is equal to 0. So now I need to rewrite it to find the value of dy by dx. So dy by dx is equal, I'm going to divide both terms by 4y. So dy by dx is equal 6x squared divided by 4y. Divided by 2 up, divided by 2 down. So it's a 3x squared divided by 2y. It's a 3x squared divided by 2y. So this is derivative of y with respect to x in terms of x and y using the implicit differentiative. Use the implicit differentiation to find dy by dx in terms of x and y. So to find the derivative, I'm going to find d by dx for the left hand side 3x squared plus 3y squared. And for the right hand side, derivative of any constant is 0. Derivative of 3x squared is 6x. With respect to x, so it's dx by dx, I'm not going to write it. But derivative of 3y squared is 6y dy by dx. Because this is y, so dy by dx. So let's rearrange it. So 6y dy by dx is equal. Moving 6x to the other side, it's negative 6x. Divided both terms by 6y. So dy by dx is equal to negative x over y. Use the implicit differentiation to find dy by dx in terms of x and y. So d by dx for the left hand side, which is 5y squared, is equal d with respect to x for 2x power 3 minus 5y. So derivative of y of 5y squared is 10y. After I put down the exponent and subtracting from the exponent 1, dy by dx is equal derivative of 2x to the power of 3 is 6x squared minus 5, derivative of 5y is 5, dy by dx. Notice that I have two terms of dy by dx, so I need to collect it in one term. So I'm going to write it as 10y dy by dx and move this from the right hand side to the left hand side, so I'm going to change the sign. So it's a 5 dy by dx is equal to 6x squared. I can't add these two terms because they are not like terms, so I'm going to take the highest common factor between them, which is dy by dx. So by taking dy by dx as a highest common factor, it's gonna be 10y plus 5. Since I have two terms outside the bracket, I should have two terms inside the bracket. Is equal to 6x squared. So dy by dx is equal 6x squared divided by 10y plus 5. And this is the value of dy by dx in terms of x and y. Use the implicit differentiation to find dy by dx in terms of x and y for 4x squared is equal to y to the power of 3 plus 4y. So by finding d with respect derivative of the function with respect to x for the left hand side and the right hand side, so derivative of 4x squared, I'm going to put down the exponent, so 2 by 4 is 8, subtracting from the power 1 is equal d by dx for 2y to the power of 3. Y is not a function in x here because in terms of y, so it's going to be 6, put down the exponent, subtract from the exponent 1, dy by dx plus derivative of 4y is 4, but also dy by dx since y is not a function in x. So I have dy by dx here and dy by dx there. So I'm going to take dy by dx as a highest common factor. So here there will be 6y squared plus 4 and the other side is 8x. So by taking dy by dx as a highest common factor, so divided both by 6y squared plus 4, so dy by dx is equal to 6y squared plus 4 divided by 8x. By the way, here you can divide each term by 2 of the 3 terms. So it's going to be 3y squared plus 2 over 4x. And this is the final answer. Use the implicit differentiation to find dy by dx in terms of x and y. For 5x to the power of 3 is equal negative 3xy plus 2. So d by dx for the left hand side, which is negative 5x to the power 3, and d by dx for the right hand side, which is negative 3xy plus 2. Derivative of negative 5x to the power of 3, I'm going to put down the exponent, so it's negative 15x taken from the power 1, so it's going to be x power 2. Negative 3xy, I should use the product rule. Let's remind you, by the product rule, d by dx for uv is equal to the derivative of the first multiplied by the second plus derivative of the second multiplied by the first. So derivative of negative 3x is negative 3 multiplied by y, plus derivative of y is dy by dx multiplied by the first, which is negative 3x. And the derivative of 2 is 0. Derivative of any constant is 0. So I'm going to move negative 3y to the other side and keep negative 3x in this side. So I can put here negative 3x dy by dx is equal negative 15x squared plus 3y. Divided both terms by negative 3x. So dy by dx is equal negative 15x squared plus 3y divided by 3x. Now what if I wanted to divide by 3? What if I wanted to divide each term by 3? So if I divide this term by 3, it's going to be negative 5. Divide this term by 3 is going to be 1. Divide this term by 1. So notice that I should divide each term by 3. And I can rewrite it as y minus 5x squared divided by x. Y minus 5x squared divided by x. Use the implicit differentiation to find dy by dx for the given function. 1 is equal to 3x plus 2x squared plus y squared. So d by dx for the left hand side is equal to d by dx for the right hand side. Derivative of any constant is give me 0. And derivative of 3x with respect to x is gives 3, the coefficient. Now 2x multiplied by y squared, this is a product rule. And the derivative of the product rule is derivative of the first multiplied by the second, and derivative of the second multiplied by the first. So derivative of 2x squared is 4x multiplied by the second, plus derivative of the second, which is 2y dy by dx. Any derivative with respect to y, I should add dy by dx. Multiplied by the first, which is 2x squared. So 0 is equal to 3 plus 4xy squared plus 4x squared y dy by dx. Now I wanted to write dy by dx in a single term. So dy by dx multiplied by 4x squared y is equal, moving 3 and 4x squared y to the other side, so it's negative 3 minus 4xy squared. So dy by dx by dividing both terms is negative 3 minus 4xy squared divided by 4x squared y. So I'm going to start by finding the implicit differentiation of dy by dx for the given equation. 3x squared y squared is equal 4x squared minus 4xy. Notice that I have two product rule inside this equation. So d by dx for the left hand side, which is 3x squared y squared, is equal d by dx for the right hand side, which is 4x squared minus 4xy. So d by dx for u times v is equal u dash v plus v dash u. So derivative of the first is 6x. Multiply the second, which is y squared, plus derivative of the second, which is 2y dy by dx, multiply by the first, which is 3x squared, is equal. Notice that dy by dx for any term that doesn't have x, or for any derivative of y, should be written as dy by dx, is equal. Derivative of 4x squared is 8x minus derivative of 4xy is derivative of the first, which is 4x, equal to 4, multiply the second, plus derivative of the second, which is dy by dx, derivative of y with respect to s dy by dx, multiply by the first, which is 4x. But I need to change the sign, so it's minus 4y minus 4x dy by dx is equal to 6x y squared plus 2 by 3 is 6 y x squared dy by dx. Now I have two terms for dy by dx. I'm going to collect it in one term. So I'm going to write it as 6y x squared dy by dx plus, after moving negative 4 to the other side, 4x dy by dx is equal 8x minus 4y. I put down these two terms. I'm moving 6x squared to the other side, so it's negative 6xy squared. Now I will take dy by dx as a highest common factor, taking dy by dx as highest common factor. So dy by dx and the remainder 6yx squared plus 4x is equal to 8x minus 4y minus 6xy squared. By dividing both terms by 6yx squared, so dy by dx finally is equal 8x minus 4y minus 6xy squared divided by 6yx squared plus 4x. By the way, I can simplify it more by dividing each term by 2, but I will keep it like this. So this is dy by dx in terms of x and y. Use the implicit differentiation to find the value of dy by dx in terms of x and y. So I will find d by dx for the left hand side, 5x to the power 3 plus xy squared, and d by dx for the right hand side, 5x to the power 3 y power 3. Notice that I have a product rule to the right and I have a product rule here on the left. Don't forget that the product rule, or the derivative of the product rule, u times v, is equal derivative of the first multiply the second plus derivative of the second multiplied by the first. So d by dx here, derivative of 5x squared, cube, I'm going to put down the exponent, so it's going to be 15x and subtract from the power 1. So it's 15x to the power of 2. This is a product rule, so derivative of the first, which is 1, multiply the second, plus derivative of the second, which is 2y, multiply the first, is equal. Here is another product rule. Derivative of the first is 15x squared, multiply the second, plus derivative of the second, 3y squared, and any derivative of y, we write down dy by dx. So we forgot here to write that derivative of y squared is 2y dy by dx, and this is a common mistake that most of the students is doing while they are doing the derivative. So don't forget that for any derivative with respect to y, the derivative of it, I should write dy by dx. So the derivative of 2y dy by dx multiply the first, which is x. So it's a 15x squared plus y squared plus 2yx dy by dx is equal to 15x squared y to the power of 3 plus 3y squared dy by dx. I have two components of dy by dx, so I'm going to move this 3 to the other side. So I'm going to rearrange the equation. 2yx dy by dx minus 3y squared dy by dx is equal to 15x squared y to the power of 3 minus 15x squared minus y to the power of 3. By taking dy by dx as a highest common factor, so dy by dx and the highest common factor, so 2yx minus 3y squared is equal to 15x squared y to the power of 3 minus 15x squared minus y power 3. So finally, by dividing both by 2yx minus 3, dy by dx is equal 15x squared y power 3 minus 15x squared minus y power 3 over 2yx minus 3y to the power of 2. Here is the final answer of the derivative in terms of x and y. Use the implicit differentiation to find the dy by dx in terms of x and y for the given 2x to the power of 3 is equal 3xy plus 1. Notice that I have here implicit differentiation. I have chain rule for the power or power chain rule. I have the product rule. So let's take it step by step. D by dx for 2x power 3, the left hand side, is equal d by dx for 3xy plus 1 all to the power of 2. So the derivative of 2x to the power of 3, I'm going to put down the exponent, which is 6x, and subtracting from the power 1. Now I have a chain rule here, so I put down the power, keeping the same function inside the bracket as it is, multiply derivative what inside the bracket. Derivative what inside the bracket. So I put down the exponent, subtract from the exponent 1, multiply what derivative what inside the exponent. And derivative what inside the exponent is a product rule. So derivative of the first, which is 3x, its derivative is 3, multiply the second, which is y, plus derivative of the second, y, derivative of y is dy by dx, multiply the first, 3x. So 6x squared is equal, let's expand this one. So I can write it as 6xy plus 2 multiplied by 3y plus 3x dy by dx. So I wanted to keep this in one term, so I will divide it both terms by 6x plus 2y, this term here. So 3y plus 3x dy by dx is equal to 6x squared divided by 6xy plus 2. This is positive 3y moved to the other side as negative. So dy by dx, sorry, let's write it 3x dy by dx is equal to 6x squared over 6xy plus 2 minus 3y. Now I need to divide it by 3x, each term of these. So dy by dx is equal 6x squared divided by 6xy plus 2 minus 3y divided by 3 over x, the same as multiply 1 over 3x. divided by 3x, the same as multiplying 1 over 3x. Let's simplify this one. So when I multiply 3x by 6x squared divided by 3 give me 1, divided by 3 give me 2, so it's gonna be 2x divided by 6xy plus 2 minus, when I multiply 3y by 3 over x, I will cancel the 3, so it will be y over x. So the final answer is 2x over 6xy plus 2 minus y over x. If you wanted to make the same fraction later, but I will accept this answer in the test, inshallah. Use the implicit differentiation to find dy by dx for the given function in terms of x and y. So I will start by finding the derivative to the left hand side x squared and derivative of the right hand side 4x squared y to the power of 3 plus 1 all to the power of 2. So derivative of x squared is with respect to x is 2x is equal derivative of power of chain rule is I'm going to put down the exponent, which is 2, subtract from the exponent 1, keep what inside the bracket. Multiply derivative what inside the bracket. And derivative what inside the bracket is a product rule. So derivative of the first 8x multiply the second y power 3 plus derivative of the second, which is 3y squared dy by dx. Any derivative of y I should write dy by dx. Multiply the first, which is 4x squared. Now the problem in how to simplify this. So 2x to the left is equal 2 multiply 4x squared, here is 8x to the power of 2 y power 3, and 2 multiplied by 1 is 2. Multiply 8x y power 3 plus 12, 3 times 4, x squared times y squared, x squared y squared dy by dx, derivative of y with respect to x. So I can move this part to the other side by division. So I can say that, or I can write that 8xy to the power of 3 plus 12x squared y squared dy by dx is equal 2x divided by 8x squared y power 3 plus 2. Multiply, it's moved the other side by division. Then this is positive, it will move to the other side by negative. So 12x squared y squared dy by dx is equal to 2x over 8x squared y power 3 plus 2 minus 8xy to the power of 3. And then here 12x squared. So I will multiply this part or the left hand side by 12 over x squared y squared, and multiply the right hand side by 1 over 12x squared y squared. So this is going to be cancelled. So dy by dx is equal 2x divided by 8x squared y squared power 3 plus 2 multiply by 1 over 12x squared y squared minus 8x y power 3 divided by 12x squared y squared. Let's simplify it. So dy by dx is equal, by cancelling 2 with 12, so it's 6, and x with x squared, so it's 6xy squared. So 6xy squared multiplied by 8x squared y power 3 plus 2, and above I have 1, minus, by dividing 8 divided by 4 is 2, and 12 divided by 4 is 3. X with x squared, so I have 1x down. Y power 3 and y squared, so I have 1y up. So 2y over 3x, which can be simplified more by expanding this bracket. So it's 2y over 3x, and 6 by 8 is 48, x power 3, y power 5, plus 12xy square over 1. So this is dy by dx in terms of x and y. Use the implicit differentiation to find the value of dy by dx in terms of x and y. To find dy by dx, I'm going to find the derivative with respect to x for the left hand side and the right hand side. This is a product rule, right? I forgot to write the sign. So notice that derivative of sine function in x is equal cosine the function multiplied by derivative of the function itself. So derivative of the left hand side, it's gonna be cosine the angle, which is 2x squared y to the power 3, multiply derivative the angle itself or the function. And derivative of the function here is a product rule, and the derivative of the product rule is derivative of the first multiply the second plus derivative of the second multiply the first. So derivative of 2x to the power of 2 is 4x multiplied by y power 3, plus derivative of y power 3 is 3y squared dy by dx multiplied by the first, which is 2x squared. Is equal to the derivative of the right hand side, and derivative of the right hand side is 9x to the power of 2 after I put down the exponent and subtracting from the exponent 1, and the derivative of any constant is equal to 0. Now let's start simplifying the term to the left. I'm going to write it as 4xy squared plus 6 after multiplying 2 by 3 x squared y squared dy by dx, and I'm going to move cosine 2x squared y power 3 to the other side, so it's 9x squared divided by cosine 2x squared y power 3. Now I'm going to subtract negative 4x power 3 from both sides, so it's gonna be 6x squared y to the power of 2 dy by dx is equal to 9x squared divided by cosine 2x squared y power 3 minus 4xy to the power of 3. Then I will multiply this part by the reciprocal of 6x squared y squared, so I can cancel that one, and I keep dy by dx. So I gotta multiply the left hand side, sorry, the right hand side by 1 over 6x squared y squared. So let's continue here. Dy by dx will be 9x squared divided by cosine 2x squared y to the power of 3 multiplied by 1 over 6x squared y squared minus 4x y to the power of 3 divided by 6x squared y squared, which is equal to, by cancelling x squared with x squared and divided by 2, this will be 3, and that will be sorry, divided by 3, that will be 3, and that will be 2. So it's y square multiplied by 2 multiplied by cosine 2x square y power 3 minus, and up I have 3. By divided by 2, and kx with the power and y power 3 with y power 2, I have y there and x down. So it's 2y and 3x in the denominator. How I can write dy by dx as a single fraction? I'm going to multiply 3x multiplied by 2, so it's going to be 6 y square cosine 2x square y power 3, and 3x multiplied by 3 is 9x minus 2y by y is 4y power 3 cosine 2x square y to the power of 3. For each problem, use the implicit differentiation to find the second derivative of the function. The second derivative of the function in terms of x and y. So first we are going to do the normal work to find d by dx for the left hand side, 4y squared plus 2, and do d by dx for the right hand side, 3x squared. So derivative of 4y squared, I'm going to put down the exponent, so it's going to be 8y, and the derivative of y with respect to x is dy by dx. Any constant, its derivative is 0. Derivative of 3x squared is 6x. I put down the exponent, subtract from the exponent 1. Notice that I didn't write dx by dx because dx by dx is equal to 1. So I need to find dy by dx in one term. So it's going to be 6x over 8y. By dividing up and down by 2, so it's 3x divided by 4y. So this is a quotient rule. So if I wanted to find the second derivative, so I'm going to use the second derivative d by dx for 3x over 4y. So d by dx for u over v is equal derivative of the first multiply the second minus derivative of the second multiply the first divided by squaring of the base. So squaring of 4y, derivative of 3x is equal to 3 multiply the base minus derivative of the base, which is 4 dy by dx multiply by the numerator 3x. Notice that derivative of y is dy by dx. This is the second derivative of y. So d2y over dx squared is equal 12y minus 12x dy by dx divided by 16y squared. We all know that we just figure out the value of dy by dx. It is equal to 3x over 4y. So I'm going to replace dy by dx and write 3x over 4y. So it's 12y minus 12x multiplied by 3x over 4y over 16y squared. So it's equal 12y minus 12 divided by 4 is 3. 3 multiplied 3 is 9. So 9x squared over y divided by 16y squared. To remove this y in the denominator, I'm going to multiply each term by y. Multiply each term by y. So 12y squared minus 9x squared divided by 16y to the power of 3 after simplify and multiply each term by y. Find the second derivative of y with respect to x for dy by dx in terms of x and y. So as normal, we are going to find d by dx for the left hand side and d by dx for the right hand side. So we are finding the derivative with respect to x. Derivative of any constant is 0. Derivative of 4x squared, I'm going to put down the exponent, so it's going to be 8x, subtracting from the power 1. Plus, I put down the exponent, so it's going to be 10y, subtract from exponent 1, but I should write dy by dx as y is not function in x. Now I need to rearrange it to write dy in dx in one term. So by moving 8x to the other side, so 10y dy divided by dx is equal negative 8x. Divide both terms by 10y. So dy by dx is equal negative 4x divided by 5y. After dividing each term by 2 to simplify it. Now I wanted to find the second derivative, so d by dx for dy by dx at the left hand side, and d by dx for the right hand side, which is negative 4x over 5y. The one on the left will give me the second derivative of y with respect to x, and the right hand side is a quotient rule, and the derivative of a quotient rule is equal to squaring of the denominator, derivative of the first multiply the second, minus derivative of the second multiply the first. So it's 5y to the power of 2, derivative of negative 4x, which is negative 4 multiply the base, minus derivative of the base here, it's 5 dy by dx multiply the numerator. Let's simplify it. Negative 20y plus 20x dy by dx over 25y to the power of 2. Now I gotta replace dy by dx by negative 4x over 5y. So the second derivative of dy dx squared is equal negative 20y plus 20x multiplied by negative 4x over 5y divided by 25y to the power of 2. So it's 25y squared negative 20y plus 20 divided by 5 is 4, and positive multiplied by negative is negative 16x squared divided by y. To simplify all of these fractions and keep it in terms of x and y, I need to multiply each term by y. So negative 20y squared, when I multiply each term by y, I am going to remove this y in the denominator. Minus 16x squared divided by 25y to the power of 3.